Welcome back to VannKit MathLab. I'm Vannessa, your VannKit tutor. In our last lesson, we explored some of the basic building blocks of geometry, points, lines, and planes. Today, we're going to use those building blocks to create something new: segments, rays, and angles. And here's our MathLab question. How can something as simple as an endpoint completely change a geometric figure? Let's find out. One line, three possibilities. What changes when we control the endpoints? Segments have 2 points, rays have 1, lines have none at all. See the difference? A segment is like a line that stops twice. These two endpoints, A and B, determine a finite piece of a line. We write it as AB with a straight bar over the top. It starts and ends exactly where we tell it to. Every point between A and B is part of the segment. Whether you call it AB or BA, it's the same finite piece of the line. Simple, right? Now for the ray. It has one endpoint and extends forever in one direction. Think of a flashlight beam. It starts at the source and travels as far as it can go in that one path. In a ray, order matters. The endpoint must be named first. Ray AB starts at A and goes through B. Ray BA would be a different ray going the opposite way. When two rays share the same endpoint but head in opposite directions, they are opposite rays. Together, they rebuild a perfectly straight line AC. What happens when two rays share a vertex? They form an angle. The vertex is that common endpoint where the rays meet. Watch it rotate into place. We name it angle ABC. The most important rule to remember: the vertex is always the middle letter. B is the heart of this angle. Standard rotation in geometry goes counterclockwise or anticlockwise. This is our positive direction. When you see a positive angle, think counterclockwise. Rotation can also go clockwise, which we consider the negative direction. Recognizing this difference is a vital skill for any geometry pro. For instance, plus 90 degrees means a quarter turn counterclockwise, while minus 90 degrees means a quarter turn clockwise. One is positive, the other is negative. Interestingly, plus 180 and minus 180 degrees both land in exactly the same position, creating the same straight angle. Symmetry in action. Now that we understand an angle as the amount of rotation between two rays, we can use the size of that rotation to classify different types of angles. Acute angles are the small, sharp ones, less than 90 degrees. Think of them as acute little angles, narrow and focused. Like a pair of scissors partially open, they're sharp and narrow. 35 degrees is a perfect example. A right angle is a perfect corner, measuring exactly 90 degrees. It's the building block of almost every structure we see. You'll find them in window frames and book corners. They are the standard for balance in geometry and in real life. Obtuse angles are wider, greater than 90 degrees, but less than 180. Imagine opening a laptop wide. That's obtuse. 125 degrees looks like this. Finally, a straight angle is exactly 180 degrees. It looks like a straight line, but with a vertex in the middle. Flat and perfect at 180. Time for a quick check. Pause the video here and decide on your answers before I reveal the truth. Think about those endpoints and angle measures. Ready? 3, 2, 1. Now, the MathLab challenge. Mission 1, build a segment. Mission 2, a ray. Mission 3, an obtuse angle. And the boss level? Build a figure from notation only. Mission complete starts now. 100 points per correct build. Great work. Here's your exit challenge. Explain each figure using precise geometric language. Focus on the endpoints, the direction, and the vertex. Accuracy is your best tool in geometry. Great work, MathLab crew. Today, you discovered how points and lines help us create segments, rays, and angles, and you learned how angle measures help us classify them as acute, right, obtuse, or straight. But now that we can create angles, I have another question for you. What happens when two angles meet? What happens when lines cross, or when they never cross at all? That's our next investigation. That's our next investigation in S01E04, angle and line relationships. Keep exploring, keep thinking, and I'll see you in the math lab.